Hello teachers and classmates. Today the title of my report is Unlocking the Potential of Drones in Revolutionizing Intercity Express Services, a Cost Efficiency Analysis. The contents of my presentation include the background, research questions, the methods, experimental results, and the policy implications. Now let's begin. The rise of online shopping and e-commerce has led to a surge in expresses. Quite a proportion of these expresses are made intercity, which usually requires short delivery times. Traditionally, most express companies are currently transporting their packages using trucks in the cities. However, it may encounter two difficulties. First, city roads are always crowded, especially in megacities. Second, the costs, including worker wages and fuel expenses, are also increasing. If we look at these two questions, drones may provide a potential solution to address these challenges as they are not dependent on ground roads. In addition to small drones for first and last mile delivery, there have been recent advancements in medium-sized drones offering potential suitability for intercity express delivery. So, in this research, we basically want to explore the time and cost benefits of medium-sized drones for intercity express services. If the answer is yes, that the cooperation of vertiports and distribution centers would bring additional benefits in terms of delivery efficiency and cost. Next, if there is one best drone mode both in efficiency and cost, if not, what trade-offs can be achieved within these drone-based modes? Finally, in order to gradually deploy drones, which type of ODPs should firstly be deployed under the limited investment condition? Now let us focus on the current delivery mode of trucks. The leading logistics companies in China typically employ a three-echelon logistics network for intercity parcels delivery. The right figure illustrates a typically out of this network. Currently, trucks operate with predefined schedules and routes that provide periodic service. However, this truck-based mode faces challenges in terms of inflexibility, heavy workloads during peak hours, and wasted payload during off-peak hours. This makes it challenging to achieve a win-win outcome of lower operational costs and higher efficiency. In megacities, multiple distribution centers are strategically placed to improve the logistics network's capacity. So we assign each order to the distribution center that minimizes transportation distance, and trucks are assigned to collect or distribute parcels from nearby stations. To optimize efficiency, we cluster stations into smaller groups based on their geographical distribution. Using a constraint-based k-means clustering method, we impose a time constraint on truck transport to ensure a quick turnover within each group. The sequencing of station visits within a group is determined by solving the well-known traveling salesman problem, so we can estimate the cost and efficiency of this truck-based delivery mode based on the aforementioned steps. As for the efficiency, we can obtain this value from the actual operational data. For the cost, we consider three primary factors that contribute to the cost, which is the driver wages, the fuel cost, and the truck depreciation cost. The parameters needed to calculate the cost all can be obtained from the aforementioned steps, such as the distance of the truck from station I to J in Group M. Now, let's shift our focus to the drone-based modes. Mid-sized drones offer flexibility and suitable payload capacity for intercity carrier services. However, important questions remain unanswered regarding the design of the drone service network and the potential time and cost savings. In this research, we propose 4 drone-based modes based on the presence of vertiports and distribution centers. Mode 1. Each station serves as a vertiport, enabling drones to transport parcels between service stations. Mode 2. Some stations are designated as vertiports, while parcels for other stations are sent to the nearest vertiports for distribution. This mode operates as a vertiport-to-vertiport service. Mode 3, similar to Mode 1, each station functions as a vertiport. However, a distribution center is involved, collecting and distributing parcels between the stations using drones. This creates a station-to-hub-to-station structure. Mode 4, with the distribution center acting as a transshipment hub between vertiports. This mode follows a vertiport-to-hub-to-vertiport pattern with the fewest service paths. Then we propose a simulation model to depict the delivery time of drone-based modes. As for the cost, we consider 2 main elements, which are electricity cost and depreciation cost. Given the limited investment, how to purchase and allocate the fleet wisely is of significance, so we further develop an optimization model that enables us to determine the best fleet size and composition. The following is our experimental results. Firstly, we conducted data analysis from the spatial and temporal perspective of demand. These findings emphasize that a small number of stations and OD pairs handle the majority of orders, while most stations and OD pairs handle a relatively small number of orders on a daily basis. As for the efficiency, about 40% of orders take longer than 8 hours to be transported, while only less than 5% of orders can be delivered within 2 hours. This further highlights the challenge faced by large load trucks. Now we can see the final results. Firstly, let us analyze the operational cost results. In the truck-based mode, drivers' wages comprise approximately 70% of operational costs, whereas daily depreciation costs of the truck fleet can be nearly negligible. By contrast, if drones are deployed, the expenditure on drivers' wages can be saved, and the cost mainly comes from the electricity and the depreciation of drones. In most drone-based modes, the vehicle depreciation cost is a predominant factor. This also indicates that the key driver of profitability in the drone-based modes is to reduce the manufacturing costs of drones or the number of drones employed. Next, we turn to the operational efficiency results. This figure illustrates that in all modes, the waiting time for vehicles always accounts for the largest portion of the total delivery time, especially in drone-based modes, where it contributes more than half of the total time. In general, when considering time-saving potential, drone-based modes consistently outperform the traditional truck-based mode. According to the aforementioned results, we can get the following 2 dominance relationships. The VHV mode is the most cost-saving mode, while the VV mode is the most time-efficient one. Other than the SS mode, the other 3 drone-based modes dominate the truck-based mode in both metrics. This implies that drones have the potential to simultaneously reduce operational costs and improve delivery efficiency if an appropriate operational mode is implemented. To further highlight the distinction between these two modes, we investigate the marginal cost associated with reducing their respective delivery times. Results indicate that the dominance between the VV and VHV modes can change depending on the level of investment willingness. In other words, if the company prioritizes improving efficiency and places less emphasis on costs, the VV mode would be the preferable choice. In reality, it is not realistic to replace all trucks with drones all at once due to the substantial one-time investment required and the significant changes in operational modes. We further conduct experiments to identify the vertiport pairs that should be given priority for drone servicing under VV and VHV modes, respectively. According to results, we found that drones can be promising alternatives for servicing short-distance pairs. Now we can answer questions proposed at the beginning. Firstly, we found that introducing drones helps improving the efficiency and reducing the cost of the intercity express services. However, there is no single dominant mode that outperforms others in terms of both metrics. Secondly, facilitating vertiports enables drone-based modes to achieve simultaneous cost savings and efficiency improvements. Conversely, involving distribution centers has the potential to save costs but does not contribute to improving delivery efficiency. If the investment is sufficiently large for operations, VV would completely dominate VHV. In the short term, deploying drones on short-distance vertiport pairs can yield substantial cost and substantial cost reductions. Finally, we give some policy implications based on the experimental results, including giving some specific permits, vertiport and hub construction, short-term drones deployment, and safety and data privacy. That's all. Thank you.